My name's Anna Dabrowski. I'm going to share my screen. All right. Can you all see that? You should see the hackathon website on my screen.
Yes,
is that right?
we see you.
Okay. Cool. All right. So first off, I want to let you know what I'll talk about today. So this session, really, I want to focus on working with tabular data in Python. So we have about 45 minutes is what Jamie told me. So we'll get through some things, but we won't get through everything. If you want to follow along, I recommend going and getting the materials that I have for this session. And they are in the HPC hackathon schedule. If you scroll down to 2 o'clock, there's my name. There are the sample files that Jamie added to GitHub. So if you go here, you'll go ahead and see all the files. There are a couple of Jupyter notebooks in here, and that's the environment that I'll be using. So if you all are familiar with working with Jupyter already, that's great. If you're not familiar, I do recommend going back to the trainings here. And I believe Jamie went over some Python development environment training in one of these sessions here, where you can learn a little bit more about using Jupyter. So if I go back here to the sample files, I have a couple of notebooks here. One is just called Python Data Carpentry, and that's all of the materials, and that includes the code. And one is Python Data Carpentry Blank, and that just includes some of the material without the code. And you can use the blank to follow along if you want to type yourself, and you can just use the data carpentry with the code, which looks like this. It includes all the Python code in here if you just want to look at what's going on and follow along.
There we go. And Anna, would you mind, there you go, that one's a little bit larger, but enlarging your font just a little bit. Thank you.
Yeah. So this is my notebook. I am working on, again, I'm working on the Hack HPC Python Data Carpentry Blank file. And then in here, I have that other notebook if you want to refer to the notebook with the code. And then I also have a couple of data files. One is an Excel file, which is XLS, and one is a CSV file. Alrighty, so I do want to encourage you to use the chat to ask any questions that you have during the session. I'll try and monitor those. But if I'm not responding, I'm just going to ask Jamie to go ahead and jump in and interrupt me and ask any questions that you have. Before we get, excellent. Before we get started, if you all could let me know in chat, have you used Jupyter Notebooks before? Have you seen it before? Or do you want me to go over using Jupyter Notebooks a little bit as well? So let me know, yes, you've seen it, or no, you haven't used it before. Let's go over it a little bit. Okay, cool. I'm seeing a lot of yeses. I see one no, okay. Haven't used it. Okay. All right, so there's some people who've seen it, some people who haven't. All right. And are you all familiar with writing code, either in Python or a different programming language? Okay, all right. So some of this will be familiar to you all, some might not. Okay, great. Python preferably, okay. Well, we'll be doing everything in Python today. So let me just quickly go over Jupyter Notebooks a little bit. So this is what the environment for a Jupyter Notebook looks like once you've launched it. You'll see a whole bunch of menu options here, but most of the work that you're going to do is here in this lower section in what are called cells. So I have one cell here and I have another cell here. It's these different chunks here. In Jupyter Notebooks, what's kind of neat about this programming environment is that you can have different kinds of cells. You can have code cells and you can also have note cells. So here you see a note cell. And this is actually markdown text. So if I click into this cell, you'll see that it's markdown format, and you can learn more about markdown format if you're not familiar with that. But basically, you can kind of code up your headers and links using markdown, and then create a nice looking little note here. And then beneath these note cells, I have some code cells. So these are cells that will actually run my Python code after I run the cell. Right now, they just have some comments. They don't include any code, but you'll see how they work once we add some code in there. And the code that these cells are going to run is kind of indicated up here. So I'm using Python 3, and you'll see that that's the interactive Python kernel that I'm using. So when I run code here, I can only really write Python. That's the only thing it'll know how to interpret. There are other languages that you can use in Jupyter Notebooks, but I'm doing everything in Python. All right, so hopefully that's a little bit of an overview. So the first thing that we're going to focus on right now in this session is an introduction to Pandas DataFrames in Python. So Pandas is a module in Python that you can use to work with your data. It's very good at working with tabular data. I'm not sure if we'll get all the way to this section, but I also have a section in this document near the end that is about working with databases in Python. So if we don't get to this section, you can go ahead and review that for yourselves as well. My aim right now is to get to the writing data to a file section, and hopefully we can also learn about merging data from multiple different data frames. But let's just get started with data frames and talk a little bit about that first. All right, so like I said, Pandas is a library for the Python programming language that provides you with data structures that you can use to work with your data, as well as data analysis tools to be able to quickly work with your data. It lets you transform your data, analyze your data, do all sorts of stuff. And so we'll go through some of the things that you can do with Pandas in this session. So data frames are used to work with tabular data. And if you're not familiar with that word, with what I mean when I say tabular data, what I mean is data that's structured into columns and rows. So you can think of that as Excel spreadsheets, as CSV files, so comma separated value files, as TSV files, or also tables in a relational database. And generally, the way that data is structured in a tabular format is that you have columns that indicate your variables. So you'll have something like a column name. Some people call this the field that they're using. Some people call that the variable. And then the data are also organized into rows, where each row is an individual record or an observation. And sometimes people use those words interchangeably as well. Usually in tabular data, you have the first row, that's your header, which gives you your column names so that you know what those variables or those fields that you're working with are. And then within each row and each column, you'll have a particular value, and that's your actual data. That's the stuff that you actually want to work with. So Jamie pointed me to the Hack HPC website, where there's a list of different data sets that you all can work with on your projects. And I went over there and I also found some data from the Governor's Office of Planning and Budget. And I downloaded that data for myself, and it's included in the sample materials that are online. And that data is for the number of housing units in Georgia by county from the year 2000 to the year 2011. And if you want to access that data set, you can just go directly to this link. If I click on it, it takes me to the governor's office. And if you scroll down here and you want to look at some of the data that they make available, it's in here. All right, so the first thing that we're going to do is we're going to bring data into a data frame. So I have this data that I mentioned saved as a file. So if I go over here to my Finder window, I'm using a Mac, so this is how I see my files. I can see that I have this file called Housing Units 2000 to 2011 XLS. So it's an Excel file, and that's the file that I downloaded from the governor's website. And that's the file that I want to read into my data frame now. So the first thing I'm going to do is I'm going to import my package. So before I can start using DataFrames, I have to get the package Pandas that I'm going to use to work with the data. So the command for bringing that package into my environment is import, and then I give the package name, which is Pandas. And I also give it an abbreviated name as PD, so I can refer to the package as PD, and I don't have to type Pandas every time I want to use it. And in Jupyter Notebooks, if I press Shift Enter, it'll run that line. So as soon as I run that line, you'll see that this little open bracket now has a number. It tells me that I ran that line as the first line that I ran. So I've imported the package. I didn't get any error messages. That worked fine. Great. So the next thing that I want to do is actually read that file in to a data frame. The easy way for me to do this is to just copy the file name. So on a Mac, I just do Command C, and I can just paste that file name here. That way I don't have to type this messy file name all by myself. And in order to read a data file into Pandas, you use a function called read. And Pandas can read all sorts of things. So if I do read underscore and then tab, we have tab completion here in Jupyter Notebooks. I can see what are the functions that I can use. What can I read? I can read CSV files. I can read Excel files. And that's the one that I'm interested in. So I'm just going to let it autocomplete for me and do pd.read Excel. So now I need to tell it what the file I want it to read is. And that's going to be this housing units file. So I could go ahead and just paste that in there. And one important thing is, so that Pandas doesn't get confused, you need to put that in quotes. And that way it reads it as a string and doesn't think that these are variables that you're working with. So if I do this, I do Pandas read Excel, it's going to go ahead and read my Excel file. But I need to actually put this data that I'm getting from the Excel file into some kind of an object I can work with. So now I'm going to create my data frame, and I'm going to assign it to a variable. And the way I assign it to a variable is just by giving it a variable name. I'm going to call mine housing underscore df for data frame. I'm going to say equals the thing that I read from this file. So I can make this variable name anything that I want. I can call it housing units if I want. I can just call it housing the way I had initially. But anytime I want to refer to it, I have to use the same name. So I can choose whatever name I want, but I can only refer to it with that name. So if I go ahead and run this, something happened, but I don't see anything. I don't see the data yet. Still haven't gotten to that. So if I want to see the data, I can go ahead and just refer to my variable that I just created, which is housing underscore df. And I press Shift Enter again. And now I finally see the data. So this data frame will show me part of the spreadsheet. I see the first few rows, and then I see a dot, 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 and then I see the last few rows. At the top, this is my header. And what Pandas does automatically is it takes the first row of your spreadsheet and it creates a header out of it. And for some reason, this looks a little bit weird. So we see housing unit estimates Georgia counties as the header for this column, but then the rest of the columns are unnamed. And what seems to be the case is that actually the first row of data is years. So it looks like the way that the data were structured in the spreadsheet was not that only the top row was a header, but the top two rows were actually headers. So here we have the year 2000 all the way to 2011, and we know that the data we're looking at is from 2000 to 2011. So Pandas, when it did this automatically, actually didn't get didn't figure out what the right header was because the data wasn't formatted the way that it was expecting. Another thing you'll see is that on the left-hand side, you have an index, and it tells you what row you're looking at. So this is row 0, 1, 2, 3, 4. And one thing to remember, if you don't already know, is that in Python, indexing starts at 0. So instead of starting your count at 1, you're going to start at 0. And another thing I want to point out about this data set is that even though it represents the housing in counties, we also seem to have values for all of Georgia, so all the counties added up. And we also have this weird row here at the end with no values. It just says na, 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 na. And that's what Pandas does if it encounters an empty cell. And then at the end, we have a little piece of information here that tells us where this data came from, which isn't actually valuable to our analysis. So we're going to talk a little bit about how we can clean this up and actually get at the data that we want. So the first thing we'll do is choose a different header instead of having all these unnamed columns here. So I'm going to go ahead and copy my code from up here and do the same thing. I'm just going to read the file back in. So I'm going to paste my code down here. So I'm going to read the same file in, but this time I'm going to give it another parameter, and I'm going to say header equals 1. And then we're going to look at this data frame again and see what happened. So if I press Shift Enter here, we're now going to see that it looks different. Now it took, oh, excuse me, let me zoom back out. Everything that had been in this row before, and it brought it up into the header. So now we have the column names being the years, which is what we wanted. But we've lost that information about the first column being the counties. So now we have the first columns unnamed, and the rest of the columns have the years, which is the way we want it. Are there any questions about this so far? I'm going to let Jamie tell me if he sees anything. Okay.
I haven't seen any questions outside of asking for the GitHub link, but people don't be shy. Please feel free to ask questions.
Yeah, so go ahead and ask questions. Yeah. This part?
Yeah, so you said like it doesn't have the name like the housing units anymore. Is there a way to make that be like after you do like the header equals 1, is there a way to incorporate like that housing units to be where that the unnamed 0 is after you run this?
Not in the way that I did it. I am not sure. I haven't usually done that. So what I'm going to do instead is actually rename a column. But I'm wondering if maybe Jamie or Junyi have done that before. I usually just choose the one that I want to be my header.
Are you talking about like?
And then work from there. Yeah, so he's talking about merging the top 2 rows into a single header.
It's not impossible to do, but I guess the question is, are you worried about displaying the data frame or processing the data frame? Because sometimes it's just more trouble than it's worth to try to mangle the headers.
So like you see where right now it says unnamed 0. I was wondering, is there a way to possibly put what you had previously there? Or like once you move the header down to 1, it's going to get rid of that data?
It'll get rid of that data, but it's not such a big problem because we can rename the column. But this kind of gets at one point that I wanted to make, which is if you have a header, put everything in one header. Don't use multiple rows to kind of distribute your header across multiple rows.
Okay, thank you.
Yeah, yeah. So that's just a recommendation for keeping your data clean, basically. Jamie?
And with her saying that, I'm going to tell you some of the data sets you download won't do that. And you will, you know, not like the person that put that data set out.
Yeah, so this is why it's good to know this, because this is one of the data sets that kind of was on the website and is distributed by the government. and yet it doesn't really use the best practices for the data.
Okay.
So just to show you what that looks like within the spreadsheet itself, if I look at this file, this is what the spreadsheet, oh, it's kind of small, but you'll see that like they have the top, they treated that as like a title.
I see.
And then they had the header. And so when you import that to actually work with it programmatically, it's messy.
Okay. Okay.
Yeah.
Okay. Thank you.
Yeah. If anyone has any more questions, let me know. Even if I'm going too slow, let me know too.
Yeah,
Too
quick
slow,
question.
too fast. Yeah.
So just curious how the mechanism of the Panda is doing. It's just reading it's just taking the whole data set into the memory, or it's reading like line by line?
It creates an object called a data frame, which is what Pandas gives you. And then you can work with that object as a whole. So it's not reading line by line.
So, in other words, if we have a really big data set, then they might challenge the memory of the machine.
So I'm not one who knows much about the memory necessarily, but it shouldn't be too much of a challenge. I think the whole point, Pandas is optimized to work with really big data sets. So I leave that to more of the computer science people around like how the code is optimized, but it's designed to be able to do transformations on really large data sets.
Okay, thank you.
Yeah. All right, so we see that we've got our housing data frame into a variable called housing, and we can start working with it. And the first thing that I'm going to do now that we have this header with the years is actually change this unnamed column name to counties, because I think that this column represents counties, even though it's got, one row that has Georgia and one row that's this non, and one row that's also this kind of the source information. We'll try and clean that part up in a little bit, but first I'm just going to rename this so that I can refer to it a little bit more easily by what I think it means. So changing column names. All right. So in order to rename a column within a data frame, I have to start with the data frame name. So this data frame is called housing df. And if I don't want to type this out every time, I can start typing it and use tab. And again, we have that tab completion that'll just complete the name of my variable because we already have that defined. So that just makes it a little bit easier. So Pandas has this function that we can call using this dot notation called rename. So I would type the name of my data frame dot rename, and then we can use that function. And now I have to tell the function which column I want to rename and what I want to rename it to. So I have to tell it I want to rename a column, and that column equals, I'll let you know what this means in one sec. Unnamed colon, I think there's a space there, 0. So that's this column name here, and that's the one that I want to change the name of. And then I'm going to say what I want to rename it to, and that's going to be, I'm going to call it county name underscore name. So what I have here is a dictionary. That's what this curly bracket notation means. And when I give this dictionary to this function with column, I'll rename the unnamed column to county name. So if I do this and press Shift Enter, oh, I'm going to get an error.
It's your name.
It's not column, it's columns. So let me try that again. Okay. Now it doesn't. Unnamed. Yeah, you're right. It is the unnamed as well. That wasn't the first error. That was the second error because it didn't actually make any changes because I misspelled unnamed. I used one N instead of two. So now if I do two N's, shift enter, finally, I get county name as my new column name. And now I can refer to this column using my new column name, which will be very helpful. But one thing you should notice here is that I saw this data frame right away. And if I now go to housing underscore DF and press shift enter, I see the old column name. I don't see the change. Do you all know why? Does anyone know?
You didn't
Yes.
update it. You just called rename, so it showed the result, but it didn't actually update the old housing DF.
Yep, that's exactly it. So I actually have to assign what I did back to the same data frame. I can assign it to a new one if I want, but I'm just going to overwrite my old variable that I've been using so far, so I don't have to remember a new one. So now if I do it that way, and I refer to housing DF, it'll now be within my data frame, and now I can keep going. All right, cool. So we've done a little bit of cleaning up. We changed the column names. We got the column headers that we want. Now what I think that I want is just the data that's between row 1 and 159. Because I don't want Georgia as a whole, I just want the counties, and I don't want this weirdness here or this extra information here at the bottom. So the way that I can get at that is by what's called slicing. So we can grab only the rows that we care about by using slicing. And in this case, we're going to use what's called the positional index. So you heard me mention indexes a moment ago, where you have these numbers here on the side. So these are called indexes. Do you have a question?
Sam's. I got a full box, but I just don't want to run out. No, but you know, I guess I get nervous.
Can you mute, Elvira?
But I guess I'm all right.
You got a full box.
Thanks. All right. So here on the left-hand side, we have the indexes or the index, and we know which number is assigned to which row. So I can use these numbers to actually pull out only the rows that I care about. And again, that's called slicing. So let's see what that looks like. Again, I use my data frame name. So tab completion, housing underscore DF. And then I'm going to use this bracket notation to refer to the rows that I care about. So within that bracket, I'll give the numbers of the rows that I want. So let's just do an example. Let's say I want 0 to 3. This is going to be the range. And if I do shift enter now, I get the first 3 rows of my data set, and that's all. I no longer see the whole data set. So that's how you can slice. There are a couple of things that I want to point out. Again, the positional indexes start at 0. So the first row is going to be 0. But another thing to note is that the rows that I got are just 0, 1, and 2, even though I gave 0 to 3. So for using positional indexes, you should note that when you're slicing, it's exclusive of the last index that you specified. So it's only going to give me up to 2. So now let's try and slice the data frame to get actually the values that I do want, and we'll then assign that back to the same data frame. So let's see what we actually want. I'm going to want between 1 and 159. So if I want to get that, I'll specify 1 to 160, and that'll get me to row 159. So let's do housing underscore DF equals, again, using this bracket notation, tab completion, housing in brackets, 1 to 160. And then I'll look at what's in my data frame. Tab completion, Shift Enter. Cool. All right. Now I have what I think are just the counties. We start at Appling and we go all the way down to Worth. Any questions on this part? All right. I'll go ahead and keep going. So what we used here to choose the data that we wanted were these positional indexes, these numbers. But maybe if you know this data set and you know the counties in Georgia, you don't want to refer to rows by this number. You might want to refer to rows by the name of the county. So what you can do within Pandas is also set your own index labels. You don't have to use the positional index numbers. So what we're going to do is try and set the counties as our index labels. And that's all the values here in our county name column. So before we do that, we want to make sure that the county names in this column are unique. Because when you're referring to something using its index, you want to refer to only one row. So if you have the county name that repeats in this data set, then you'll get more than one row if you try and use the index. So that might be the case if the data are messy, if someone accidentally included the same county twice, or if for some reason Georgia has multiple counties with the same name. So the first thing I'll do is check if the values I have in county name are actually unique and if I can actually use this column as my new index. So there's a neat function to do that. Again, I have to access my data frame, housing DF. And in this case, I'm going to use bracket notation to specify which column I want to look at. And the column I'm interested here in is county underscore name. So that's what I renamed my column to, and now I can refer to that column with this new name. And you might have noticed that I used only a single quote here. In Python, that's interchangeable. You can use a single quote, or you can use double quotes, and it'll mean the same thing. It'll treat that as a string. So if I say, look at my data frame housing, look within county name, and there's a neat function to tell me if the values within that column are unique, and that is the is_unique function. So if I press Shift Enter here, I get true. Cool. Pandas automatically tells me that every value here is unique. This isn't super informative if you kind of want to see a little bit more of what's going on, but it's a lot easier. It'll just tell you true or false, is it or isn't it? It's a lot easier than looking at the row and counting the number of times that something shows up, especially if we have 159 values in that row, or in that column, excuse me. But let's see what it looks like if there were duplicates within the counties. So what I'm going to do is actually create a new data frame with an example of duplicates. So what we did initially was we imported a data frame from a file. What I'm going to do here is actually create a data frame and just add some data that I make up into that data frame. So I'm going to create a data frame that I'm calling counties_dup_df, again for data frame. Just kind of a note of what kind of object I'm working with. And then in order to create one, I use PD pandas, again, data frame. And then I tell that data frame what data I want to put into it. So I'm going to just copy and paste from my notes here to make this a little bit faster. So the data I'm going to give it is Appling, Atkinson, Bacon, Appling, and Baker. So these are real county names, but in this case, I have a couple of that repeat, and we're going to see what happens. And then I also have to define my column. So I'm going to call my, columns equals, I'm going to call it the same thing, county underscore name. All right. And then we'll look at what's in that object. Counties underscore dupe underscore df. Cool. Now I just made myself a little tiny data frame to play around with, and it has one column, that's the county name column, and it has these values in it. All right, so now if I just want to see whether or not it thinks that this is unique and how that works, I can just do counties dupe df, bracket notation, county name. Here I'm just using single quotes. And again, that is unique function. And now it'll tell me false. Great. So now I can trust that it's actually telling me true or false if it is or isn't unique. Since this is a small data set, we might just want to take a look at how many times each of these repeats. And we can also do that. So I'm just going to copy part of what I just typed down here. So again, the data frame and which column to look at, and I'll give it a different function. This time I'm just going to give it the function called value counts. So it's going to count the number of times a certain value occurs. And if I press Shift Enter here, it'll tell me, well, appling happens twice and all the others once. And this is why the is unique gave me false. All right, so that was a little bit roundabout. But basically what we know is that in our original housing data frame, the county name column has unique values. None of the values occur more than once, so great. We can use it as our index. So then we can refer to rows by county name instead of using the numbers. So let's first make this column county name into an index. So there's a function to set the index in your data frame. And that function is, again, called the data frame dot set underscore index. And then you give it the name of the column you want to be your index. And that for me is county name. And this again, I'm going to go to the front and assign this to a variable, which is the same data frame that I've been working with so far, just to make sure it gets saved to that variable. And we'll go down and take a look at it. So if I do Shift Enter now, I'll see that county name now occurs a little bit lower here. So that's the name of my index. The column names are up here. And then all the actual county names are now in bold. So that kind of indicates to me that now these are the index and I could refer to these county names to get a particular row of data. Any questions about that before we start working with that index name or those index labels that we created? One neat thing I want to show you, because so far every time I've been looking at the data frame object, I've been looking at the whole thing, is a little function that can show me just part of it. So I don't have to have this huge thing that I scroll down and look at. If I just want to see the first few rows, I can use a function called head. And I can give that the number of rows that I want to see. So I'm going to say 5. Oh, I'm going to have to do this in a new, X that out and then run it. So the reason I couldn't do that twice is I had already set the index. So county name was no longer a column I can work with. And so trying to refer to it as a column again, the second time broke it. So I just commented that out. All right, but the head function worked. So now I can just look at the first 5 rows, or I can look at the first 10 rows if I want. Shift Enter. It'll give me the first 10 rows. So that's kind of a neat way to reduce the data that you're looking at if you just want to run things and take a look at them from within this window. You can also look at the last rows. So if I do housing df.tail instead of head, and also give that 5, let's say, Shift Enter, I'll see the last 5 rows. So we see Whitfield down to Worth. All right, we're getting close to time, so I'm not sure I'll get all the way to writing data to a file, but let's do selecting values using row and column labels, and then we can open it up to any questions, and maybe we can save a file if we've got a little bit of time. All right, so there is a function in Pandas that lets you refer to columns and rows using their labels. And for rows, those labels will be the index name. So for me, that's county name here because that's what I specified. And for columns, that will be the column name. So the function we're going to use is called .iloc. And the way it works is that first you give it the row label that you want to access, and then you give it the column label that you want to access. So let's take a look at how that works. So again, I'm working with my DataFrame object, DataFrame, and then using .loc. Then in brackets, let's first just get it a row label and see what happens. So if I just do Wilcox and press Shift Enter, I get all the data for Wilcox, but this now is a series. It's no longer a data frame. What if I also want to specify which columns I want? I can do that. Let's say I just want the year 2000. It'll give me a single value. So Wilcox for the year 2000 is 3,353 housing units. And that's the value that I was able to pull out by specifying which row I wanted and which column I wanted. But we can also get multiple rows and columns that we're interested if we just want to mix and match and choose a few that we want to look at. So here, what I'm going to do is choose a range of rows and a couple of columns that I want to grab. So let's do, in this case, Whitfield, or no, let's do a different one. Let's do a new one. And I'm sorry if I'm mispronouncing the names of these counties. Tretlin, Trutlin. Let's do Trutlin to Twigs. So that's going to be a range. And then let's just do a couple of years. And the way I'm going to choose a couple of years is by putting them in brackets. So this indicates that I'm giving it a list. It's going to be 2000 and 2011. So just the first and the last years. Let's say we just want to look at those. If I do Shift Enter now, I get a little tiny data frame, and it still has a county name as the index. And then I have the data for just 2000 and 2011 for the range of counties that I specified.
Can you get just the Chartlin and Twigs by putting a comma between the strings in this function?
Let's find out. Comma. So I can't, so if I just run this, let's see what happens. It breaks. What I need to do is also put brackets around this again. Because if I'm just giving like one thing, another thing, Pandas needs to know to treat that as a list. And the way that I indicate that is with the brackets. So let's see if this works now. If I do the brackets around those two. Yeah. So now I get just Tretlin and Twigs.
I have a question. So earlier you did Tretlin and Twigs and you just put a colon in between. But so when you do that, it's inclusive to Twigs in that case?
Yeah. Yeah, isn't that a weird thing? With the positional indexes, it's exclusive of the last one. But with the labels, if we have an index that's the label, then it's going to be inclusive.
Okay,
yeah.
That's interesting.
Yeah, and that's a really good point. So it's just something you have to remember.
Okay, thanks.
Yeah. All right, Jamie, how are we on time?
So we're at 2:48. So
Okay.
I think we can do one more. So I think the
right.
functions on columns is important.
Yeah, I think this is more interesting than saving files. So let's quickly do that. Maybe we can also save a file. If not, the code is in the notebook that you all have access to, so you can also just see that, that function as well. All right, so math functions on columns. So what's neat about this data set is we're looking at, if I just go back up here, we're looking at how housing units, or the number of housing units in these counties, has changed over the years. So we can ask questions like, did the number of housing units increase or decrease between 2000 and 2011 in a particular county? And so what I'm going to try and do is find out what that looks like by using a little bit of math on my data frame. All right. So the first thing I'm going to try and answer is, how much has the number of housing units changed for all of the counties in my data frame from 2000 to 2011? So the way I do that is pretty simple, actually. I first write my data frame name, and then I'm going to say 2011 is the column that I want data from. And I want to take the data from 2011, and from that, I want to subtract the data in my housing data frame. Oh, excuse me. That's in 2000. So what this is going to do, let's see if it'll give me an output if I just run this part. It gives me an output, is it just gives me the values. So I get Appling had an increase of 677. Atkinson had an increase, Baker had a decrease. But if I actually want to add that back into my data frame so I can see everything in context, I again have to assign that to a new column. So what I'm going to do is, instead of just doing housing underscore DF, since this is just a series, I can't just assign this to my data frame and get a data frame, because this is just a list with an index. I need to assign it to a new column. So I'm going to create a new column within my data frame called housing underscore change. And then I'll look at my data frame again after I've done that. And if I press Shift Enter now, you'll see I get my full data frame with all the data that was there before. And then I've just appended or added that housing change data that I got from my subtraction as a new column here at the end. So one thing that I notice here is that actually some counties had a decrease in the number of housing units, which is kind of surprising. I generally just like expect it always grows, everything grows. So it might be interesting to actually try and pull out which counties had a decrease, just to see what happened there. And maybe you can also look at that in the context of other data that you find. So if I just want to pull out all the negatives and I don't want to have to like look at the whole spreadsheet to do that, I can subset my data using criteria. So I'm going to quickly give an example of doing that, and then I think that'll be all that we can get to. So now that I have this housing change data within my data frame, let's try and use it to subset the data frame. So instead of subsetting just by the county name or just by the column, we're going to subset by some of the actual data that we have in here. So there are different criteria that we can use. We can do equals, not equals, less than, or greater than. In this case, since I'm trying to find negative numbers where housing decreased, I'm going to use less than 0. So we're going to try and find all the data where the housing change was less than 0. All right, so let me try and type that in for you. So to find that, we'll do housing underscore DF, and then we'll use that bracket notation again. And we're going to do something a little bit fancier here. We're going to do housing underscore DF again, which just looks a little bit weird. And now we're going to refer to the column we want to look at, housing change. And we want to get everything that is less than 0. All right, let's make sure I closed all my brackets. And let's see what happens if I do that. Cool, it seems to have worked. Now I get only the rows where housing has decreased. So we can see which counties the number of housing units has decreased in between these years. So there's kind of something funky happening here. Before, when we were using the bracket notation, we were only referring to a column name or a row, but here we actually like plop in the whole data frame name and then refer to a column and then have this criteria that we're using. So what we're using here is actually called a Boolean mask. And what that means is that if I take away the first part of what I wrote, and if I just use this function, this criteria, what I'm going to get is just true false values. It's going to tell me for this county, false, it's greater than 0. For Baker, true, it's less than 0. So the housing change is less than 0 or greater than 0. And then what I do when I add this housing df here is I say, give me all the rows in the full data frame where this is true. So what I end up getting back is my full data frame and only where those values were true. So Baker, we see again where it was true, we get the actual data. So that's why you have that strange nesting in here. All right, I think that's really all I've got time for.
All right.
Any questions?
So Anna, I'm going to say for me, thank you for showing me the Boolean mask. That is irritating. You don't know about it. So yeah. I now know how to do that.
Good. I'm glad I was able to teach you something too. All right. Stop my screen share.
All right,
so again, there's more material in the notebook that I shared. And so you can go through that.
For those of you that are also considering using Jupyter Notebooks, which I know a lot of you are, we did do a section. There is a training session. If you look at the main Hack HPC/HPC site, there is a training session that we did specifically for you all on setting up your Jupyter Notebooks environment using either Google Cloud or using Google Colab to make it a little bit easier. Some of you all are accustomed to using Jupyter Notebooks on your personal computer. We want you to use it in the cloud because it gives you a couple things. One, it ensures that you can share it with your teammates. Two, it ensures that you can that you have used an HPC resource. Hint, hint, hint. But at the same time, if you or your mentors need assistance setting up Jupyter Notebooks for your team, just let us know. And Anna, thank you. Thank you so much.
My pleasure. I hope you all got something out of it.
And so now I get to blackmail her. So Anna, if we happen to have questions, could we
please contact me with any questions?
Yes.
Jamie has all my contact info.
Yes, and actually, what I'll do is I'll also add you to our Cloud Hack Slack.
Yeah, that's great.
One more channel for us, and that way you'll be a part of it. Thank you so much.
Hey Anna, could you please post the link to the notebook?
Yeah.
Yes. So we've posted it a couple times here in the chat as well as in Slack, and I think she just did it one more time.
Yeah. Cool, thanks.
Yep.
I don't know why I didn't see the others. Thanks a lot.
All right. Well, beyond that, folks, I will see you all tonight at 5 o'clock my time. No, so 5 o'clock my time, 6 Eastern, and 3 Pacific. Yes. And to answer, Max actually asked me a question. Yes, if you're using Google Cloud to stand up a Jupyter Notebooks instance, you're using HPC resources to do that. It's a cloud resource. So yes. So some of you all are going, oh, I could do that. But either way, if you have questions, let us know. All right. Thank you all so very much. I will see the mentors at 4 my time, 5 o'clock Eastern, 2 o'clock Pacific. And then the rest of you all at 5 o'clock my time, 6 Eastern, and 3, right? Yes, Pacific. Time zones, they're a thing. All right, have a good day, and I hope everyone's doing well.